Hi everyone, and welcome to this lesson on two-proportion test. What I'm going to do here is just to work through a very simple example. It's just an exercise that I use when I'm teaching this in classroom. Before I start though, I just wanted to point out that I am using SigmaXL software for this statistical analysis. You can check them out on their website, SigmaXL.com, and learn about their products there. So let me remove this title here and let's get going. I'm going to bring out the data that I have for our exercise, and I'll explain what we're doing here. So basically this is a claim from the marketing department of this cookie manufacturing company, that what they're saying is that in 2015 they gave away on the street cookies to people that were just passing by, and they interviewed 500 of these people, and 160 of them said yes to the question, do you like your cookies? So they simply said yes. It was a yes or no type of question. So that's 32%. So the marketing department then is claiming that in 2016, they did the same exercise, the same survey on the street, and they interviewed 600 people, of which 219 said yes, we like your cookies. So the claim is that there's been an increase in percentage of favorable answers. Basically, they're saying that more people, proportionally speaking, are saying yes to that question, which means that they like the cookies, proportionally speaking, even more. So that's the claim, that's the data that we have to work with. Let's have a look on the things that we have to set up before we actually run the two-proportion test. So normally what we need to do is to state the hypothesis and also set your alpha risk, your significance level that you're willing to work with. So the null hypothesis here is very simple, and as always, the null hypothesis will tell us that there is no difference, there is no change, there are no news, nothing has changed. So basically we're saying that the proportion of yeses in 2016 is the same as the proportion of yeses in 2015, no change. The alternative hypothesis says, or at least the claim, says that the proportion in 2016 of yeses has actually increased, is greater than the proportion of yeses in 2015. And I'm going to set the alpha risk at 0.05 or 5%, which is very a normal, reasonable, acceptable alpha risk for this type of analysis. So it's important that we set this up prior to the test that we're going to run. And that's what I did here. Let's get to the test then. We're going to go to the SigmaXL menu options here. So as you can see, there are a lot of different things. I'm going to open the Statistical Tools menu and then go to Basic Statistical Templates, all the way down to Two Proportions Test and Confidence Interval. Before I start doing anything else, I just want to make sure that my alpha is set to what I wanted to set to, so it is 0.05. And then just to make it a little simpler, I'm going to clear this out so I don't get confused on the numbers here. So simple one, which is my 2016 year. Again, I'm trying to prove that 2016 is greater than 2015, so that will be my simple one. If you recall, we had 219 yeses, so events, or some software or some textbooks will call it successes. So 219 yeses, successes, events, people that said, yes, I like your cookie, out of a sample size of 600. So that's the most recent year. And then the previous year, 2015, we had 160 yeses or successes out of 500. So that's just the data that I had set up in the exercise. The hypothesis, the null hypothesis, again, it's that there are no differences, and a different way of writing the hypothesis here, that's what SigmaXL is doing here for us, is that it equals 0. So if something minus something else equals 0, it means that there is no difference. There are no changes. There are no news. So the null hypothesis then that the difference between the proportions is 0, and then the alternative is that that difference is actually greater than 0. So we're trying to say if the proportion in 2016, proportion 1, is actually greater than proportion 2, which is 2015, this number has to be greater than 0. It has to be a positive number. I'm saying that 2016 minus 2015, proportionally speaking, has to be greater than 0 for it to be actually a greater proportion. And that's all you have to do, really. What we can see here is that because my alpha risk was 5%, my confidence level is 95, so it's 1 minus your alpha risk. We have the results on Fisher's exact and Newcomb-Wilson score. The results table here will show my proportions, which is what I had if I just go back to the formatting here. Percentage is exactly what I had on that previous spreadsheet. The sample proportion difference is that 4.5%, my alpha risk, and then my p-value. My p-value is 0.0667, and as we know, if our p-value is greater than my set alpha risk, which in this case is 0.05, I will fail to reject the null. I'm going to keep the null. I don't have enough statistical significance or enough evidence that those two proportions are actually different. In this case specifically, the proportion 1 is greater than proportion 2, or that my 2016 survey results has a greater proportion of yeses than my 2015 survey results. Now, I am pretty close, but again, that's why it's important to set your alpha risk beforehand so that you can run the test. So otherwise, you go back and forth and try to adjust to change the outcome. Not a very good scientific practice. And that's it for proportion test. The only thing I wanted to show you is that SigmaXL will also give you these results and interpretation on the right side here. As I had mentioned before, I have a null hypothesis in green. It says fail to reject. I have no evidence or not enough evidence that proportion 1, in this case 2016, is actually greater than proportion 2. And then interpretation of p-value and confidence intervals on this side here, which is basically, in different words, what I just said in terms of the outcome of the test. So, and this is it for the 2 proportion test using SigmaXL. I hope you've learned something here, and I hope to see you again.